Hey there, STEM Spark enthusiasts. I'm so glad you're here. I'm Courtney, and welcome back to the STEM Spark, where we ignite curiosity, creativity, and confidence in every learner through science, technology, engineering, the arts, and math. Today, we are diving into a wonderful household science superstar, vinegar. The thing I love about vinegar is that it's inexpensive and versatile. You've probably used it to clean or to cook, but did you also know that it is a steam powerhouse? With just vinegar and a few simple materials, you can explore chemistry, physics, art, and engineering right from your kitchen or your classroom. So grab your apron, a few cups, and get ready to fizz foam and have some fun. So, I've got several experiments for you. We're going to kind of walk through them. I'm going to tell you what you need, what to do, and the science behind it. And I'm not going to actually do the experiments in this video, but I am going to make a just for kids video that will have the experiments done in it. So, if you are interested in that, stay tuned. All right, so the first experiment we're going to talk about today is the classic baking soda volcano. So, of course, you're going to need some vinegar, you're going to need some baking soda. You will also need a cup or a small bottle. I have this. You could also use like a mason jar or just a regular cup. You could use something even smaller. You're going to get the same reaction. And so, if you're doing this on a bigger scale, you could use smaller cups so that your materials go further, whatever you need. And then you can always do food coloring, which makes it even more fun, and a container to catch the spills because they will happen. All right, what do we do for the volcano? We're gonna put few spoonfuls of baking soda into your cup. The more you put in there, the more reaction you're gonna get. You're gonna put, if you're using food coloring, you're gonna put the food coloring in with the baking soda. Okay, and then you can measure out some vinegar and pour that on top, and it's gonna immediately create a bubbly eruption. It's so fun. Okay, so the science behind this is an acid-base reaction. This reaction happens because vinegar, an acid, reacts with the baking soda, a base, to form carbon dioxide gas. The gas, of course, forms bubbles, creating that fizzy, foamy lava effect. When they combine, they produce three products. Carbon dioxide gas, CO2, it forms the fizzy bubbles and the foamy overflow. It's also going to create some water, H2O, and then the third thing it will create is sodium acetate, and that's a salt that stays dissolved in the liquid. The carbon dioxide gas is what gives the volcano its eruption. This experiment introduces ideas like chemical change, a change that cannot be undone, gas production, so creating those bubbles, that gas effect, and then it also gives you the solid liquid gas option to talk about. So if you're talking about states of matter, this is a great way to kind of introducing some of that, or to even follow up with a fun experiment and talk about, okay, what is the liquid, what is the gas, etc. Okay, some of the questions you can ask is, what do you notice happening right away when the vinegar touches the baking soda? So they're going to start observations right away. How could we change the reaction? So, do we want more reaction, less reaction, more bubbles? And so, getting them thinking in those lines of like, would I add more vinegar? Would I add more baking soda? Do the ratios, how do they play into the amount of gas? So, those types of things would be a fun extension and letting them try a different variable. And then what do you think is making all those bubbles would be kind of a lower thought question for younger grades. How does it make the bubbles? What is happening? Okay, so that is our simple volcano, baking soda and vinegar. All right, for our next one, we're going to incorporate some art because who doesn't love a little color? Our next experiment is called fizzing color art. So, what you'll need is you could do it in a container like this, but I would say a tray or like a cookie sheet is even better. You're going to need vinegar, baking soda, definitely food coloring or liquid watercolors for this one. And then you need a dropper or a spoon. So you could use a spoon as long as you're just super careful. I would have them not fill the spoon up just a little bit in the spoon, so that if you're doing this with a class or a small group, it's just a little bit at a time. So what you're going to do is you're going to take your tray and you're going to sprinkle baking soda in a very thin layer on the tray. You want it covered, but not super thick. And then you are going to drop spots of food coloring across the surface. Now, if you are really wanting to dive into some art concepts, I would say kind of put certain colors beside each other so that they mix and react, and you can talk about how all of that works out. But anyways, you're just going to do drops of color across the surface of the baking soda. And then you're going to use your dropper or your spoon to carefully add vinegar on top of the color. So right on top of where you put your dots of um, food coloring, you're gonna drop just a little bit of vinegar, and you can do more as you go. And watch the colors fizz and mix and make beautiful foamy art. It is so fun. So the science behind this, again, is using the same acid-base reaction, but it highlights these observable changes. A key part of the scientific investigation is when vinegar reacts with the baking soda, it releases those CO2 bubbles that mix the colored liquids. And so when those color liquids mix, it creates those different hues and shades and colors. And so that fizzing motion stirs the colors in a way you can't really do by hand. And so it's letting kids visually explore color theory and chemical energy release in a really fun and engaging way. The reaction is endothermic, meaning it absorbs heat, which is why the surface sometimes feels slightly cool. So you could even pick it up and feel the bottom of the pan. It's the same acid-base reaction, but here we're exploring the chemical reactions along with the color mixing. When colors combine, it's a little chemistry and a little art and true steam. So a few questions you could ask is, what new colors do you see forming? How could you make the reaction last longer? And what happens if you tilt the tray after the reaction has kind of slowed down? So that's also fun. There's lots of extensions you could do with this. I mean, the sky's the limit. And so it's super fun to incorporate that art component. Okay, experiment number 3 is the vinegar rocket. So for this one, you will definitely need an outside space. You're gonna need a film canister that has like the little click in lid, a small container with a tight lid. It cannot twist, it just has to pop top. Or if you have prescriptions, sometimes if you go to the pharmacy and ask, they'll just give you a bottle. But like a prescription bottle with the non-safety lid should work. Because it's going to function much like a film canister would. So you're going to need your vinegar, your baking soda, and a small piece of paper. So what you're going to do is pour a little vinegar into the canister. You're gonna wrap a small amount of baking soda in a paper square, like a packet. So I would say you could use regular paper, you could use tissue paper, you could use a tissue, like whatever you want. Cut it into a small piece, put some baking soda in the middle, and then fold it up like a little packet. You're gonna drop it in the container, snap on the lid real fast, and then step back. And in a few seconds, it's going to pop and your rocket's going to launch. So it would even be fun to like decorate the bottle like a little rocket. It is also fun if you put the cap side down so that the container is what shoots up. That's super fun. So, the science for this one is still that acid-base reaction, but now we're harnessing that gas as a pressure, and it creates this pressure to do work. In this case, launching the rocket. And so, when the CO2 gas builds up in the closed container, the internal pressure increases until the lid can no longer hold it, which is why you want that pop top, not the screw on, right? So when it pops off, the gas rushes downward and the canister shoots upward, demonstrating Newton's third law of motion. For every action, there is an equal and opposite reaction. So it is fun to make sure you're pulling in that component of where is the gas going, and then what is that opposite reaction, and how do we see it? So those types of things. The more gas produced, the greater the force pushing on the lid and the container or canister, and then it's going to have a bigger reaction, right? Changing the amounts of vinegar or baking soda changes the pressure and the flight height. So that could be a great extension if you all do the same thing to start and then have each group change one variable, whether it's the amount of vinegar or the amount of baking soda, up or down, to see what happens. Is super fun extension, and it gives them some of that student choice, which we love. Okay, a few questions you could ask. What do you think made the canister pop? How could you make the rocket go higher or faster? That's a good one. What do you think would happen if we changed the size of the container? So also a fun thing to think about for them to kind of analyze. And even you could have those things available if you're going to do an extension and let them choose what thing they would like to change. Okay, so that is the rocket, the vinegar rocket. Now we're going to go on to experiment number 4, vinegar and eggshells. The bouncy egg. This experiment takes a couple of days to complete, so just kind of front load your brain with that. You will need a raw egg. It does have to be raw. You will need some vinegar and a cup or a jar. I would say this is not my preferred jar for this activity because you do want to take the egg out and it's hard to get out. So something with a wide mouth or a little bit more open, like a cup, it I think is actually better for this activity. Because I'm gonna have to reach in and grab it or use a spoon or what have you. So the bigger the opening, I think the better. So what you're gonna do is put your egg in the jar to start. You're gonna pour the vinegar over the egg until it's completely submerged. I would leave a little bit of space at the top even. So you want completely covered in vinegar with a little room, and then you're going to leave it 24 to 48 hours. Immediately, you're going to start to see those bubbles forming around the shell. After 2 days, or more or less, depending on your location and all of those things, you're going to carefully remove the egg. It should feel soft and rubbery. Okay, so let's talk about the science with this one. When you submerge an egg in vinegar, bubbles start forming almost immediately, and that's that CO2 reaction again. The vinegar, the acid, reacts with the calcium carbonate in the shell. So the acid, it starts to dissolve the shell and produces calcium acetate, which is a soluble compound. It produces water, and then it produces that carbon dioxide gas, CO2, which is the bubbles that you're going to see. So, after a couple of days, the shell disappears, completely dissolves, leaving only the semi-permeable membrane beneath. And so, this membrane allows water to pass through by osmosis, making the egg swell slightly. So, the result is a squishy, translucent slightly bouncy egg. You cannot bounce it from a great height, but if you hold it kind of close to the table, it does have a little bit of that bounce, which is so fun. So, a few questions that you could ask for this experiment. What changes do you notice on the egg after a few hours? What do you think the bubbles, or sorry, why do you think the bubbles form around the egg when we submerged it in the vinegar? What do you think would happen if we tried this with a hard-boiled egg? That would be fun. Another extension you could do, I did this with my fifth grade class when we were studying the human body, is the egg acts like a cell. And so if you dissolve the shell, it has that semi-permeable membrane. And so we put it into oil and watched what happened to the egg in oil. And then I took it out of the oil, which it shrivels up. And then I took it out of the oil and put it in water. And we watched what happened when we put it in water. And it was a really great conversation, even about nutrition and how your cells work and how it's passing through. So, all of those things are super fun and a great way to extend this activity, even a, for a week or so, because it does take a few days for each one to materialize. But it's super fun. It's a great one, especially for the not only the conversations, but the science behind it is really fun. All right, the big takeaway for today, with just vinegar and a few everyday materials, you can explore chemical reactions, pressure, color theory, and even biology. These simple experiments show that science is everywhere, and creativity makes it even more fun. All right, STEM Sparkers, I'll leave you with this final question. What experiment would you want to do next? Can you use vinegar to clean or make something you could eat? Remember, every fizz, pop, and color mix is a spark of discovery. Thanks for tuning in. Don't forget to follow the show, leave a review if you're loving it, like this, subscribe to the channel, and share it with a fellow educator, parent, or STEM enthusiast. I'll be back next week with more ideas to keep your STEM from ever fizzing out. This is Courtney with the Sim Spark, where curiosity sparks creativity. Bye.